All right, let's do more practice with chemical tanks. So in particular, let's set up a system Q prime equals AQ plus B for the following configuration of chemical tanks, where Qi is the salt in tank I. And before I show you the picture, setting up a system here just means find the matrix A and the constant vector B. You do not need to solve the system. So without further ado, here's the system of, or the configuration of chemical tanks. So 6 liters of minute of water in 1/3 kilograms per liter of salt. That concentration goes into the first tank. And then the rate out is 4 liters per minute, 4 liters per minute, and then 3 liters per minute also goes out. And I know it seems a bit like paradoxical, but here assume the amount of water in each tank is constant, meaning that water can evaporate out of each tank. So it does make sense. Now, no matter what the configuration is, always think how much is going in and how much is going out. So we want to use the in and out equation. And out, not the burger place, but the math equation, meaning that the rate equals rate in minus rate out. In minus rate out. So let's look at the first tank. First tank. So we want to figure out the rate of change of the first tank, that is in minus out. So let's see how much is going in. So 6 liters of minute of water and then 1/3 kilograms of liter per salt. Qi is in kilograms, so the rate of change is kilograms per meters per minute. So in order for this to make sense, you just multiply both of those. So 6 times 1/3. 1/3. And then how much is going out? So the rate is 4 liters per minute. And then how much, like what's the concentration in there? It's Q1 over 2. So it depends on how much there is in this tank. So minus 4 times Q1 over 2. So in the end, it becomes 2 minus 2Q1 of T. That's the first tank. Now let's look at the second tank. It's like Shark Tank, but with math. So Q prime of T, again, is in minus out. So now let's look at the second tank. How much is going in? Well, it depends on the first one. So Q1 over 2 times 4. How much is going out? Q2 over 4 times 4. So it depends on the second tank. So in this case, 4 times Q1 over 2. And then minus 4 times Q2 over 4. And so in this case, we get 2Q1 of T minus Q2 of T. And last but not least, let's look at the third tank. So Q3 prime of T So how much is going into the third tank? Well, all of the second tank, so Q2 over 4 times 4. How much is going out? It depends on the last tank, so Q3 over 3 times 3. So Q3 prime, that is 4 times Q2 over 4 minus 3 times Q3 over 3. And so this becomes Q2 of T minus Q3 of T. So I can always think in minus out. So to summarize, what is our system? So let's first write this in terms of sort of algebra lines, and then we'll do it in terms of matrices. So Q1 prime of t, so that's minus 2 Q1 of t plus 2. So plus 2, and Q2 prime of t, that is 2 Q1 of t minus Q2 of t, and then Q3 prime of t. It was Q2 of t minus Q3 of t. And well, if we want to make it in terms of matrices, we have to figure out how much Q2 and Q3 also in this equations. So 0 Q2 plus 0 Q3. Move that a bit. 0 Q3 plus 2, and then here we have 0 Q3 plus 0, and then 0 Q1 plus this plus 0. And so now, in terms of matrix form, this is of the form Q prime of t equals AQ plus B, just like me, a QD, and where? So A is the matrix minus 2, 0, 0, 2 minus 1, 0, and then 0, 1 minus 1, and B is 2, 0, 0. The queen bee. And once again, I want to emphasize, you do not need to solve the system. The question was just set it up. And that's precisely what we did here.